For the full countdown. I can hop on before my little countdown gets to 0. That's no big deal. But I do need to turn off the light. The light does not look good. Let's turn that off. All right. Hey, I'm Eric. I'm making animated faces. And it's for a larger project, but I'm not going to get into the whole project thing. It's going to be real cool, but I just don't want to plug it right now. It's early days. It's time to build the blocks, to build the pyramids. Let me demo what I did over the weekend. I had a productive day off stream. Sometimes it's good to just do a bunch of work off stream because you can kind of get your thoughts in deeper places that way. But on-stream dev has its own benefits as well. Let's go take a look at what happened. All right, so here's my face. I figured out some stuff. Okay. So first off, a quick demo. Here's all the emotions: neutral, confused. So the eyes up here are now drawing partially how they will. They're a little closer to completion. There's some debug information that is being drawn here, which looks maybe a little strange, but these red crosses here, I'll explain that in a minute. That's just part of my debug visualization. All right, afraid, evil, suspicious, amused, happy, thinking, angry, irritated, and then the mouth movements, which I had a few days back. And this rest thing gives the bottom half of the face permission to show the emotion up top. So the emotion affects the eyes up above, and it also affects the mouth below. Okay, so the part that I did, which is, if I may compliment myself, a little bit clever, is this automatic masking. So here's what my sprite sheet looks like that I'm using to draw the eyes. Okay, that's the whole thing, but let me explain the parts. Okay, so these guys up top that actually look a little bit like eyes, those are what I call the overlay. I should go in order, in draw order. Let's go in draw order. The first thing that gets rendered is the eye back, which is, the whites of the eyes. On top of that, the irises are rendered. On top of that, the lids. Okay, well, I have them all be separate parts. The irises move independently of other artwork, as do the lids. The eye backs, they got to be there because something's got to be behind it all. Otherwise, you're just looking at background, like you're looking through somebody's face. Okay, then this overlay, which goes on top, was an interesting problem. The overlay that goes on top of everything needs the interior transparent pixels to be the only part that it allows these other assets to show through. So if I draw the eye back first and then I draw the overlay on top, if I were only just doing a regular blit, it would look like this. All the stuff that was intended to be hidden behind the face would not be present. The way I solve this originally was these used to be opaque pixels that were part of the face graphic. Here, let me see if I can find a quick example. Here's an example. So I used to just say the whole top of the head is that overlay. But because I want to have what I call Mr. Potato Head rigs, where there's mix and matchable mouths and eyes, I did not want to include all the opaque pixels around the eyes in the overlay, because they couple those eyes to a particular face, and I want mix and match. I want Mr. Potato Head. So there's transparent pixels here, and there's transparent pixels in the interior. So the exterior transparent pixels, I want, the face, the rest of the face to show through there. This is what the face looks like, right? So I want, this skin around the eyes to show up on the exterior of those eyes. So the better way to solve it is to create a mask that'll be used to limit some renders to just blit inside of the eye. And I did accomplish that. Now there isn't like a separate image that contains the mask. The mask is generated at runtime when the image loads in. So there's actually like a flood fill algorithm that looks at this entire rectangular area I'm circling with my mouse. I guess circling is the wrong word. Circumnavigating with my mouse. And it distinguishes between exterior transparent pixels and interior transparent pixels. And then beyond that, I actually go in and find in each of these eye assets inside of the mask, what are the centroids of the two masks. So all that's done programmatically, and that means that's 2 less steps to do an authoring. Like if I was going to use authoring, when I say authoring, I mean going into Photoshop and authoring assets to specify the mask, I would just basically be doing something like, circling that, selecting out like this area and creating something that looked like a mask, and I'd have to make sure I did it in the same way that the engine expected. Okay, if I was using authoring to specify where the center point was for the eye area, I would, draw a little red dot or something, some kind of encoded signal that said where it was. But what's better than that is to programmatically identify all the pixels that make up the interior eye area and just find the centroid based on all those points. And that's just averaging all those points together, and you get a centroid, and it works great, even with these irregular shapes. Like this is not a circle, it's not a rectangle, it's something else. It's a mutt shape, it's irregular. So if you look at like where these red lines are they're all converging. Here, I'll get even closer. They're in the centroid, and that is a calculated centroid. And the centroid moves around depending on the pixels inside of this eye area. So I go neutral, confused, sad, afraid, evil. See, evil, it scrunches down really far. Now the human eye doesn't actually do this. Like if you scrunch your brow really low, the center of your eye doesn't squeeze out like that, but it's okay because I want to make cartoons. I don't want to make anatomically correct faces. I want to make cartoons, right? And that's actually, as silly as it is to think of your eyes as squeezing around as you move your brow or scrunch up your face. It is kind of fun to look at, So I go sad, and the center of his eye kind of moves up a little bit. Go angry, and then it squishes out over here. It's all right. The other thing I did, and I've stopped short of doing this about 3 times on 3 different projects in the last 2 decades. The other thing I did was I defined a traversable area for the irises that's based on the interior shape. So these lines that extend out, they're basically saying something about how far it is to get to the edge. And I didn't do all of the lines. There's actually 20 lines that are defined. They're like a little ray cast from the centroid out to the border or the perimeter of the interior eye area, and they go doot 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 doot. We can see this better actually. I'll go into here. Let's make this a constant. Extend factor equals 1. Negative extend factor. Negative extend factor. Okay, so it's going to be like that. So we do that. And do Control H, and we will replace 0.5 with extend factor. Do replace, 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 replace. Okay, this is a little bit easier, I think, with it to have them go all the way out to the edge. So, in an initial ray casting, I found the collision points for 20 different angles, and here I'm just showing 9. But those angles can be used to determine how far the iris will go when it's drawn inside here. So I can allow the iris to go all the way to this little corner down here, because it'll still be visible. Just to kind of give maybe a little better of a demonstration, let me go grab my irises, and I'll just kind of drag them along inside of Photoshop, and then you can get ideas of how that works. Okay, so your irises are in here, and I can have this one go all the way down here. Now, there are a few problems with this being a single asset. Like right now inside of Photoshop, I've got one layer with both eyes. So it is kind of nice for just, in a very simple way, keeping the 2 eyes lined up. But what if the shape of the 2 eyes is fairly different? Or like one is a little bit smaller than the other? You don't actually have to have a symmetrical cartoon face, right? You can have somebody that's got a squinty eye and a wide open eye, right? Well, then we want to do something like say, okay, move the left iris at a 0-degree angle from the centroid, say off to the right, to say it's straight across, okay? And then we could say take it to the 100% to the right point, or 100% extended point on that 0-degree angle. Well, because I've got them all together as one graphic, I can't have this iris on the right be in a little bit in this direction. So today what I'm going to do is I'm going to write some code that automatically detects left and right irises inside of the space that they're at inside of the sprite sheet. And hey DZ, good to see you. I'm doing pretty good. So I'm going to have some code that programmatically determines how to split this asset of 2 irises into a separate iris, left iris, right iris. and that will allow me to use it with my fancy definition of the traversable area inside of each eye. I'll call them eye sockets for the iris, and then I can move one iris over a little bit over here, another one slightly different over here, stuff like that. It will match up even if the two eyes aren't completely symmetrical. And a really nice thing about this is I won't have to shrink my rectangles. And all the other times I've implemented this, I will put rectangles inside of here. I won't have to shrink them in to avoid the irises looking bad in certain cases. I won't have to manually adjust those rectangles to get the irises to look correct in all the different situations, because this area inside here is no longer defined by a rectangle. It's defined by the actual shape of the eye socket. All right, completed my little intro spiel. I'm going to start working a second here. But DZ, yeah, I hope you're doing good. I'm coughing a bit because I went out for a jog and I haven't really run too much recently, so it kind of did the good thing of bringing up stuff from the bottom of my lungs that I probably don't want. All right. Oh, it's middle of the night for you out in Germany, but I'm trying to remember. Was it Frankfurt? Is it Frankfurt that you're close to? Or is it Stuttgart? Frankfurt, okay. Yeah, my memory's not terrible. So you're on vacation. You're a free man. Oh, free zombie. You can wander the streets at night and not worry about where you're going or any obligations. You doing a home vacation? Cool, cool. All right. I am just a little bit excited about this session because I got to such a good point in yesterday's session. It's going to be fun to keep going with it, I think. At yesterday's session, I totally offlined it. I don't know, I just got into a groove and I didn't feel like going online. But that's okay. I get in different modes. Okay. So thinking about this a little bit. Here's my onload. This is not so wordy. I would do better to refactor it. Then I'll have a cleaner looking function. Let's see, we'll go. Not the init data, but the base offsets. The base offsets get returned into the iComponent state. Okay. Init data to base offsets. Init data. And let's actually make eyes, init, data. Init, data. Alright. No. Eyes, init, data. Okay. And that's going to return base offsets. Move this up here. And I don't think this is great. These will all be 0. All of those will be 0 because I didn't correctly. Oh, no. Okay, I got it. Okay, so this comes up here. This will be eyes in it data. Okay, bam. Okay, I'm going to say return this stuff. Then I can get a bunch of junk out of that function. Go. Base offsets and say init data to base offsets and pass in the init data. And okay, that looks better. Okay. I think I just did something easy to warm up my brain a little bit. Okay. So then I want to be able to split these eyes. And it's probably going to happen inside of load bitmaps. Or generate emotionals, actually. That's the one. Okay, so let me think. No, it's not. It doesn't go under emotionals. Those are the ones that are based on individual emotions. It's the irises. So image to iris. Let's say bitmaps. Image to iris bitmaps. Is that what I want? Wow, I do know that I want left iris bitmap. Boy, there's going to be some information that goes along with each iris though. So I probably want to create a structure for that. Let's call this type iris info equals. Okay, so we'll say iris bitmap. Okay, what was the other stuff I want? Center X, center Y, number. Okay. Image bitmap, I think that has a width and height to it already, so no need to repeat that. Okay. So if that's the iris info, then I want 2 iris info in here. One for left, one for right. Left iris. Iris info. right iris. Iris info. Okay. So for this, let's do something like const, I think left iris, right iris equals image to left and right irises. That probably works. Okay, go left iris, right iris. Okay, but this will be await. Then have to write this guy. Just gonna be a promise for iris info, bam bam, like that. We'll return 2 of them. Okay, just so this makes the squigglies go away, let's return, gonna do const left iris, right iris. Yeah, there's no constructor in that. That's not a class. Yeah. Iris info, just do this. Just to stub it. Make the squigglies go away for a little bit. Not the most important thing to do, but I guess when you're using the squigglies to show work that you still need to do, it's kind of helpful. Okay, image to left and right irises. Passing image, not S. Okay, cool. Okay, this changes to left iris, right iris, left iris, right iris. I think just for now, let's take out any kind of rendering for the irises, because I just need to get a lot more stuff ready before I can do that. Okay, so then coming back up to this image to left and right irises. Now let me think about my algorithm here. So it's going to be get pixels, the image. Okay, this is my first solution. I'll say for the whole sprite sheet image. Okay, then add a bounds to my flood fill class. Because if I get the whole sprite sheet image and I want to do a flood fill inside of it, then I need to be able to specify boundaries to stay inside of. Okay, let me think. Okay, flood fill. From perimeter to learn exterior transparent pixels. Okay, and then typewriter scan. To discover unfilled areas. Contiguous unfilled areas. Let me see. I think I've got some find opaque area centroids. Basically follow a pattern of this existing function I wrote yesterday. Find opaque area centroids. Okay. It should return 2 contiguous unfilled areas. Okay, so then copy contiguous, let's see, we'll say first 2 contiguous unfilled areas into bitmaps. Get centroids. And above, and I have those centroids, and then return populated iris info. Okay. So that will probably work. Number 2, same as number 1, except copy pixels into new image data instances for copy the iRect pixels to new image data instances. That's probably better, to be honest. That's probably better. So in either case, I have to take the sprite sheet image and get the pixels. In either case. But in number 2, I don't have to add this extra complexity to the flood fill class. I can just use the image data. I don't yet have any reason to think that copying things around inside of image data is a big CPU intensive thing. Although I do get nervous about that. Like there's a thing when you're working with a browser implementation is you can assume something's fast, and then you find out that there's something you're doing that actually on some browser and on somebody's machine takes a lot of time. So hopefully I don't walk into any traps like that. We'll see. Okay. So let's say we'll go with this number 2. Cicada. Yeah, you got here just in time to hear me coughing and wheezing. I went out for a jog and it made my throat and lungs really itchy. But yeah, I'm back. I've been back, but I'm more in the mindset I was on earlier when I was streaming all the time. So let's call that the grind. Yeah, you're going to get the first electronically transmitted COVID from me. All right, so this is bam. What's been going on in Victoria for you? Assuming you're still in Victoria. Oh yeah, and DZ, I remembered where he lived too. It was weird. Somehow I'm remembering where everybody lives. Maybe I have too much information. No, man, Victoria, that's like Canada's best attempt at being like England. It's all that high tea stuff happening in Victoria. All right, so let's see. Copy the iRig pixels, iRig pixels and image data instances. Okay, is that a hard thing? I don't think it is. I think it should just be built into image. Am I right, wrong? Alright, gotta do a little research. Copy. Oh, pixels. That's right. Okay. Okay, so there might be a better way to do this, but let's just start with this function. Man, this is maybe a useful enough function. I'll put it inside of ImageUtil. Okay, export function. Image data subsection. Image data area to image. Slice image data. Okay, there we go. Say Yeah. And you have a good memory. Remember that. Yeah, it's 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 a similar approach. Um, I actually recreated like a simpler version of transforms. I have like a class called Canvas Component, which has got like a hierarchical 2D coordinate system and stuff. Um, but yeah, but you know, we're all off on the web now with this project. Image data. Let's see, source. Yeah, it like only took me like maybe 2 hours to make a competent hierarchical 2D rendering system. I'm sure it'll be insufficient in a lot of ways, but it's not a black box. It is not a black box. Real glad not to have a giant million line code black box to deal with. That Unity stuff. Okay, so from source image data, I want to get pixel data, got source pixels, source image data, pixels, and or not pixels, data. I should make just a quick check to make sure there isn't just a ready written copy or blit inside of here. So let me check before I go and write something easy and fun but still time consuming. Okay, so the pixel is going to give me raw pixel stuff. Don't want create image bitmap. What will the constructor take? It will take a data array, width and height. Data array, I'm assuming, is the pixel data. Okay. All right, so let's go see what the recommended ways are of doing this. Copy, let's see, JS, copy image data to another. Yeah, exactly. And it's also a little bit treacherous getting advice from web programmers about anything performance related. They generally think of very slow ways to do things. So I gotta be a little on guard. Alright, so I can do a set. I mean, like functional programming just on its own. That functional programming trend. Which I got no beef with, except that its practitioners will not even acknowledge that there might be a less functional way of doing what they're doing that's faster. Yeah. Yeah, so this is the thing that I was going to do. I just kind of know right away it's non-optimal because it's all like a JavaScript compiled loop here. But I might just throw it in to start with and I'll abstract it with a function. I feel like I might be moving some of this code to WebGL in the future anyways. So I don't want to get too bogged down on it. But what else is here? Put image data. How to clone image data. So inside of a context, I could put image data into the context. This has a chance of running faster. Okay, so I do have my context. Oh, this is the question. Does it work? Oh, yeah, it works. Okay. Image data constructor, yeah. The problem is that would be like a complete clone of the two images. If it was just a section of it, then you have to go and copy the parts you want. Okay. I do like I can do a data set. I do wonder if now this is a 2D array right here. So there's not going to be any like two-dimensional or x and y and width and height. Did I say 2D array? It's a 1D array. This is a 1D array. Not to be snarky, but that was a terrible answer. Canvas 2D is what I'm using as well. That's built into the browser. It's interesting that Crosscode doesn't use like Canvas 3D with all the 3D stuff it's doing. So Canvas 2D will be hardware accelerated and use like the 3D capabilities and the GPU and all that. But you don't get like all the spatial tricks that you can do in 3D for 2D games, putting like one sprite in front of another by using the extra axis. I think shaders probably work with it, but I haven't looked into it. But yeah, it's pretty heartening if Crosscode was totally done in Canvas 2D. That's probably a decent game for me to read up on what they did. Okay, so what I'm getting here is that for splitting a section of an image data to another section, I've got like some byte copying to do on the CPU, and I can optimize it later if I need to. Another thing that works in my favor is this analysis of these left and right irises. That could be done. If I find out this is slow, I can cache the results, and then it becomes something that doesn't have to be performed every time. So I'm not going to worry about optimizing it right now. So with that in mind, I need to specify what I'm copying. So we go X number, Y number, width number, height number. Okay, and then we create a new array, const dest pixels equals width times height times pixel size. Bam. Okay. Then we gotta do some copying. So it's gonna be we'll do a constant for row size. Row size equals width times pixel size. since I'm already calculating that. Okay, new uint 8 clamped array. It's going to be height times row size. Okay, so then it's just copying from one array to the other. Let's do for let source y equals. Let's see. I think I made a. Get pixel offset, that's it. Get pixel offset with x, y. And let's make this explicit. Source x, source y. And okay, let's keep on revising my algorithm as I write it. That won't hurt anything though. Okay. Source y equals that. Okay, let row I equals 0, row I less than height. Okay. Then I was like wishing for a mem copy here, but let's see. This could be right offset. Okay, read offset. Ninja, I can't believe it. Got all the old timers on here. Not to call you old. I mean, I'll call myself old, but I mean the GK OGs all on here. It's great. How's it going? And oh man, okay. I've remembered two cities now. I remembered where DZ was from. I remember where Cicada was from. Ninja, you're from Scotland. But I don't think I'm going to remember the city. I think you told me it's like a smaller one that's near another one. Yeah, DZ, he's over in Germany, and he's up at 2 a.m. too. So you're in good company. Near Glasgow, that is it. But oh, tell me the city. I might remember it later. I don't know why I'm trying to make it my new thing now, remembering cities. It was Clydebank, okay. Okay, read offset equals, no, this is the read offset here. Okay, read offset. Write offset equals 0. Okay, and then const. Yeah. I find it's motivating to go stream, because then it makes me think like, I got to get some stuff done for the stream, even though nobody gives a shit really. Somehow it makes me go a little bit. So, okay. So let me me get down to business here. What's going on? Okay, so I'm saying row size, but that is the row of what? That is the that's the destination row size. Width times pixel size. And source row size is just the width. No. Source row size is the width of the image data. Okay, source size equals source image data width. Okay. And then I'll say source row leap equals source row size minus dest row size. Boom. Okay. We go. Dest pixels, right offset. So I gotta do another. Okay. Right offset equals source pixels okay, those cannot be consts, they have to be lets. Okay, and then let's do const stop read offset equals read offset plus dest row size. No, dest row size, like that. Okay, we say while read offset not equal stop read offset. Okay, so that'll handle one row. And then I want to do a leap on the read offset to the next row, plus equal source row leap. Okay, so that should do the copying. That's reasonably efficient, except for this inner loop here, which is like a lot of JavaScript scrambling, like I would have hoped for something kind of like a mem copy, but I don't think I'm going to get it. It can be optimized later. Okay, down here, I want to return a new image data with the dest pixels. I have to say the width. Let's go see what it's expecting. Okay, data array and width would do it. But I feel like since I've got height, I'm just gonna give the height too. So we'll go dest, not dest row size. It's just gonna be width and height. Okay. So let me just saving. You know what, Ninja? You know what? This thing auto saves. It auto saves all the time. It's really good that way. I want you to feel safe I want you to feel secure. Yeah. But you know what also does? Even though it's already saved it, it always gives me a save all if I want to use it. But it's kind of like when you're on an elevator and there's a button to close the door, and the door will close just the same way it was going to anyways, even when you push it. It's like placebo effect. But I can go up here anytime I want, do save all. Little security blanket up there for me. All right, so this has got like a 32% chance of working on the first try. Let me think, how do I want to test this? I could write the code to just kind of blitz onto the screen. I could unit test it. If I do unit test it, dude, just boil up a pot of coffee. Let's keep going. Let's do 8 hours. We'll both show up to work tomorrow completely trashed. All right, I think. Yeah, just I'll design an idle game for you, where there's just a button, you click save. Just click save every 2 seconds. Yeah. Okay, add. Uh, 5:36. I can keep going on this until I've got about 25 minutes left. Okay, describe. Image tool. Okay, import. What was the thing called? Slice image data. Yeah. And that goes there. We do describe. Slice image data. Okay. And let's make something that creates a fake image data. You can make it so that when it's the average click time, the person waits longer than normal. So I think that's how you create a bipolar trap. Function create fake image data, and then some little let's do just an array of strings, I guess. Let's see, pixels, and then that's an easy way to specify them. Just like that. Being done. Okay, number. Okay, create fake image data, and that returns, bam, image data. Okay. Pixel data equals. Alright, Ninja. Have a good sleep. Sleep is important. Oh yeah, this. I don't want to get overwrought here. Let's see. Const pixel data equals uint8 clamped array, and that's going to be const pixel data size equals pixel. Let's see, const height equals length, and then width equals pixels 0 width, okay, or length, and pixel data size equals pixel equals width times height times 4. Wait, you missed my plane? I don't understand. Oh, you mean the outside plane? You're right. There's planes all around me. Yeah. Yep, the airport and everything. Yeah, it's not so bad living next to an airport. Okay, and if I return this fake object as image data, just put the stuff I need inside of it, and it's going to be data pixel data. I can just do, if I rename these to be the same, then I can just have it going like that. And then width and height, and that could work. All right. So then let's do it. Slices an entire set of image data pixels. Okay, there we go. I think it's just going to be bam, 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 and then oh, I also have to copy these values into it. Okay. What? 0, 1 less than height. Typoing really bad today. Okay, what's wrong with that? Why do you not like that? Oh, because you have to start with let's just do it this way. No, that's right. Okay. So data. Okay, read offset equals 0. And we say data push pixels let's see, x, y. What? What am I, oh, what? Okay, what is the, oh, maybe I just need to do a set like, oh, wow, if it's too quiet, it messes you up. Okay, fake, do. God, this is going to be such a pain in the ass. I think I'm just better off to write the code that outputs this. Otherwise, I'm just going to have so much conversion between like arrays in my unit tests and visual data. So I could create like some pretty good tests and stuff here, but then like I have to take the image data that comes back and kind of decode it again. And it's not gonna be worth it. Let's delete that. Okay. So I just need to write some code that does something with this, and I can see if it's kind of working or not. Okay, so for that, let's make sure I haven't broken anything yet. Is this still functioning? Okay, good, it's functioning. Okay, cool. Alright, then let's go to eyes. Eyes, where are you? I got too much stuff open. Okay. Oh, it's right here. Eyes, there we go. I was already in it. Well, this is just kind of a junky debug function. I could throw it in here. Okay, so what do I got that I can use? Yeah, just throw it down here. Okay. Okay, so if I say const image data equals, let's see, slice image data, and then I'll take it's an annoying part about HTML5 is these conversions you have to do. image bitmap to image data. Okay, and let's take just any of these. We'll take the lids bitmap. Okay, and this needs to be in a weight. Okay, test image or slice image data equals source image data, and then we want to grab this from, let's say, the left half, 0, 0, CXIs divided by 2 CYIs. Okay, then let's draw this to the, what? Wait, no, that's not it. What's your complaint? Let's type any because it's not have a type annotations referenced directly or indirectly. Slice image data. Did you not add it up here? It's right there. Export function, that's fine. Over here should have return type of image data. You do. Good, that looks fine. So what's the issue? What's the issue? Oh, you're already balking on that. Okay. Yeah. Draw slice debug. And we'll pass in lids bitmap. And I can make this an async function, which allows me to do a few things more simply. Fixes that. And what's the deal with this? Slice image data. Oh, I happened to name it the exact same thing. Okay, so test. Okay, and then I also need to have a canvas for it to draw to. So canvas or a context, I mean. Okay, so we'll do that. And then it's just context, draw image, test image data. And we'll just put it in the top left-hand corner of the canvas. Then I have to make a bitmap. Const test image bitmap equals create image bitmap, and from the test image data. The bitmap format is what? What? Oh, that's right. Wait. Those are some good squigglies, though. They're actually pointing out real errors, real mistakes I made. Okay. So if I come back here, I don't know if it's done anything at all. It would have showed up over here. I'll go ahead and refresh. Anything different now? restored here, so there shouldn't be any issue with the masking. Alright, time to step through it. Oh, I got about 5 minutes. Let's see if I can debug this in 5 minutes. Probably not. Okay. Let's see. Source image data populated. Good. Expected width and height. Test image data. Now here's my function that could go do crazy stupid stuff if I've got bugs in it. So I'll go ahead and step into it slowly. And bring this guy over here. Okay. Source pixels. Should be a whole bunch of them. There are. Okay, cool. What did I pass in? I passed in the lids bitmap. So if I go to the middle of it, I should see some stuff populated. Yep, there's pixel data right there. Okay. Dest row size. What do I expect that to be? Let's see, the width. Okay, the width is half of the total area, the total width of the image data. Let me just check the source image data. Width is 250. Okay, good. And this width, which I should honestly rename to dest width, just so I can keep it straight. It's 128, so that's correct. Dest row size is dest width times pixel size, so it's going to be 128 times 4, like 512. So dest row size 512. Source row size. Okay, this is wrong. This would be width times pixel size. So this is going to say 256, but that's incorrect. Okay, it should be 1024 basically. Source row leap, the offset from the end of the right position of a row. No, the read position of a row to the next row and the start of the row inside of the source pixels. This will be incorrect because my source row size is incorrect. Dest pixels height times dest row size. That's probably going to be correct. Let's see, what's the height is 128. Okay. Read offset. Pixel offset. It should be a so source X and source Y is 0 and 0. Okay. So it's gonna it's gonna read from 0, 0. Which means read offset 0. Yep. So far I've only found one bug in this that I can see. Row, go from the top to the bottom, fine. Stop read offset plus dest row size, that one's correct. While we're gonna copy. Okay. So this is gonna grab some pixels that are in bounds, but over too small of an area. So fix the one bug that I saw. Also, I'm going to change this to dest with dest height. Good names help me avoid bugs and clarifies my thinking. Okay, this is times pixel size. Okay. Dest height. Dest width. Dest height. Okay, we'll see how that does. I say this has got a 51% chance of working the next time I try it. And regardless of whether it works or not, I'm going to end the stream because it's time for me to start working on dinner. Or working on ordering dinner. So here it is, moment of truth. It worked. Okay. I know what I'm doing. My little pixel copying thing works. And that's the victory point for my session. I gotta stop now. I'm glad I got that little bit done before I ran out of time. But I'll come back. I'll get some more done. DZ, enjoy your 3 a.m. or so. Cicada, awesome to run into you again. I'm going to take off, grab myself some dinner. Alright, fellas. Stopping the stream. Stopping the stream. Stopping it. Stopping the stream.